I'm making sure this one goes in there, dude. I just recorded the entire thing and it didn't record. That's irritating. But what I am going to do is I'm going to go over it again, but I'm not going to do all the work again. All right, so number one is adding up everything and finding what's left out of 180. Simple triangle stuff. Number two is finding a scale factor. So you know that you're having an enlargement, which means you're going to have a scale factor larger than 1. The way that you would work backwards on that is starting with your image and going back to your pre-image. So like 36 over 9. 36 over 9. That's how you'd work backwards and divide. You get 4. And you can always plug it back in and go like, okay, so I take 9 and I multiplied it by 4 and I got 36. Yeah. All right. This one comes up multiple times. If you see these parallel lines and you throw an x in there, you're setting up a proportion and you're solving for it. Simple as that. So this is a proportion. Just keep in mind these parallel lines are super key in what you're doing. Parallel lines, parallel lines, parallel lines set up a proportion. This is a line cutting through a triangle, creating two similar triangles. We know that because these angles are congruent. So I set up a proportion, did the whole equation. Okay. The only thing you got to remember is whenever you're doing 28 times x plus 2, distribute 28 times x, 28x. 28 times 2 is 56. That's how this happened right here. So this is another proportion. And just there's a trick at the very end of this one. So it's easy to find x. X is 4. That's not a big deal. But it's asking you the length of CE. That's going to be the thing that's going to make you get it wrong. So from here to here, this red line, x plus 12 is the length of C to E. That's x plus 12. 4 plus 12, 16. What did I say about parallel lines? Boom, there they are again. It tells you that y is 30. Parallel lines are going to be at the same degree angle. So that's what makes them parallel. They'll never touch because they're at the same exact angle. So if y is 30, that means this is 30. And z is 70. So all you got to do is figure out what's left. You got 30 plus 70 is 100. Take it away from 180. X equals 80. This one is very similar to number 4. So this is like a number 4 clone. Set up a proportion, solve it. What did I say about parallel lines? Parallel line, parallel line, parallel line. Just choose a side, set it up. Choose a side, set it up. Another proportion. Okay, this says write a similarity statement. Just make sure that you're choosing the order correctly. So A to B to C, that's a triangle. So that means we start at D, went through the hypotenuse, went to C, DEC. ABC is similar to DEC. And then all you do is set up corresponding sides, 11 and X, 24 and 44. Just make sure you have it in the right order. So 11 and X, 44 and 24. These have 2 steps. First, you have to demonstrate that they're similar. And how do you do that? Well, if you have a big triangle that turned into a small one, you know that you have a pre-image and you know you have an image. So take your image, work backwards. 4 over 16 equals 1/4. Okay? You can also do this. Set up a proportion. 20 over 5 equals 12 over 3. So 20 times 3 is 60. 5 times 12 is 60. That's how you know they're similar. Cool. Now we know it's similar. The only possible choice you have is side, side, side. It doesn't even show any angles are congruent. So this one's obviously, yes, they are similar, side, side, side. The same exact thing as what we did right here applies to this. Whenever you have this set up, you'll have 23 over 13, and then you'll have 32 over 16. Automatically, you can see that they're not going to be equal, but I'm going to just go ahead and do it anyway. So 23 times 16, 23 times 16 is what? Wait, equals 368. All right, I guarantee you the other one's not 368. 32 times 13. Let's find out. I know the answer. So do you. 32 times 13. 416. Proof that they are not similar. So the answer is no, they're not similar. So it's not going to apply to angle, angle, or side, 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 or side, angle, side. Parallel lines again. Because of those parallel lines, and you're given 0 numbers for sides or shown any other type of angle, the only thing it could be, since you're not given sides, is angle, angle. And these parallel lines, just like I said before, are going to prove that they are similar. This one's almost as simple as matching the picture, honestly, but you have to prove that they're similar first, just like we did in the 3 problems before. So 4 to 2, 12 to 6. If you set up any of these other problems, this one might be similar, but it doesn't have congruent angles. It's got to have the same angles too. So if they're similar, they're going to have the same angles. Parallel lines, again, this is the big one for you. If you see parallel lines, you know that they're similar, and you're going to go with angle, angle. Don't try and get complicated. This is us working on our dilation. So it goes A to B. Pre-image is A. Image is B. Okay, so to work backwards, all I did is choose the coordinates right here and right here. 1, 2, I wrote up top, and then 3, 6, I wrote on bottom. It gives you the scale factor. Number 17, the only thing to watch out for is you're not comparing sides, so that's why I eliminated A and C. But the thing you have to watch out for is congruent and similar. You're not given any side measures. There's no proof that they are congruent, but there's proof that they're similar because the angles are congruent. For triangles to be congruent, they have to be the same size and shape. We have no proof of their size, only the shape. That's why they're similar. Number 18, this is like a reference point for you to use 29 degrees to plug into this other triangle, because it's asking for the value of x. So you have 119 plus 29 plus 8x equals 180. Solve all the way through it, and you'll get x equals 4. 19, 20, 21, and 22, straight up proportions, setting them up again. Corresponding sides, just make sure the information matches up. Number 24 was a note that if you see a fraction, make sure to turn it into a decimal by dividing the fraction. 1 divided by 2, and it'll turn it into a decimal. It turns into 7.5. Not that that's going to be the same exact problem, but if you do see a fraction, turn it into a decimal. This is another proportion. What did I just say about parallel lines? There it is again. A replicate of number 3 all over again. Same exact routine. Proportion. Proportion. And the rest are all proportions as well.